Good morning. I'm Sophie Rovner. Welcome to this news briefing from the 254th National Meeting and Exposition of the American Chemical Society here in Washington, D.C. We're joined today by Dr. Agenor Mafra-Neto from ISCA Technologies. He's studying ways to eradicate mosquitoes by appealing to their sweet tooth. Dr. Mafra-Neto.
Thank you. So semichemicals are the chemicals that modulate the behavior of animals, and they are very difficult and expensive to manufacture, and they have a very short life when you spray them in the field. I created ISCA Technologies, a company based in California, to solve these problems and bring semichemicals, green semichemical solutions to mainstream ag and deal with pest control in a much more safer way. Today we sell semichemicals all over the world for agriculture, but conventional mosquito control, they basically blanket spray out these sensitive areas, houses, etc., with these harsh chemicals all over the place. And today, mosquitoes are still killing 800 million people a year. So because of that, we decided to start targeting mosquitoes with our green technologies. Today, I'm going to report on 3 novel semichemical technologies that allow us to effectively and inexpensively, that's very important, to manage mosquitoes. The first technology is called Trojan cow. Trojan cow disrupts the cycle of malaria transmission. Malaria mosquitoes, especially in the sub-Saharan area, they blood feed almost exclusively in humans. They seek humans for blood, and they don't go to other animals. What we decided to do was to create Trojan cow to make cows and goats smell like humans, so we could trick mosquitoes into feeding into these husbandry animals. The deal is that if we treat this livestock with deworming formulation like ivermectin, the mosquitoes that are feeding on these cows and goats, they die. So you get an attract and kill in these villages. The second technology is a green larvicide called splatback. And usually in Africa, you have these huge floodplains all over the place that when it starts raining, they flood and mosquitoes start ovipositing and all over the place, and you get this huge population of mosquitoes coming and biting people. One of the problems with Africa is they don't have a lot of infrastructure. So when it rains, roads get impassable. You don't get, people cannot treat these areas. So we develop a formulation that uses Bacillus thuringiensis and other green larvicides, hold them into the space where we spray into these floodplains, sits there, and when it rains, the formulation and the water accumulates, the formulation detaches, floats to the surface, and the formulation starts releasing this pheromone that attracts ovipositing, gravid female mosquitoes, and they come to these areas that have been treated with the larvicide and lay their eggs there preferentially. What happened is that now, when the larvae hatch, the formulation also have an attractant that attracts the larvae. So now the larvae are going to eat preferentially this formulation, and the formulation has this bacterium that kills only mosquito larvae. So you end up with a very, very safe formulation that attracts and kills larvae. The third formulation that I want to talk is a formulation, I don't know if people know about this, but mosquitoes have a very sweet tooth. Every day they go for sweets. They're like me, they like chocolate. So the deal here is that even a female that is looking for blood, we can detract that female from going for a blood meal and bring them to a sweet meal. So what we develop is a formulation that has all the components that are attractive in flowers, like the odors that are attractive in flowers, to bring these mosquitoes to this formulation. The formulation is sweet, the mosquito is attracted, feeds on the formulation, and the formulation has tiny little amounts of green insecticides that kill the adult of the mosquito now. We just finished a very large field trial, at least large for us, 8 villages, 1,000 houses in Tanzania, where we applied this formulation to the to the walls of the buildings in these villages, and we got extremely good reduction of the number of mosquitoes that we could find inside these houses. It works beautifully. It worked great. So these three novel semi-chemical technologies are more effective than conventional control because they attract the mosquito and induce the mosquito to interact with the formulation. Okay, so only tiny little amounts of insecticide are used to control very large populations area-wide. Now, there's another thing that I hate a lot, is ticks. I went running in the Long Island last week, and I came back with 5 ticks. I hate that. I want to eradicate ticks from Long Island at least. So the deal here is that we develop an attract and kill formulation for ticks, and our first field trial has shown that we have extremely good success with that formulation too. It's an attractant that works in very, very small area, like a few centimeters. So you have to put all these little dollops on the vegetation near your house, but it attracts those nymphs that are around. They manipulate those tiny little dollops as if it was another tick, and then they die. I love dead ticks. Hey, thank you. Any questions?
If you have a question, please state your name and affiliation before asking it.
Hi, so it's Kath O'Driscoll from Chemistry and Industry magazine. I'm interested to know, how much do you think you could actually reduce the amount of insecticide by using these chemicals?
It's a tremendous amount. And we did all these calculations for agriculture. And when we have when you do blanket spray, for example, to control pests in soybeans, you use like a truckload, a tanker truck of insecticide. When you use our formulation for the same area, you use 1 barrel of insecticide. So it's a tremendous amount. And here is even more, because now instead of putting the formulation all over the place, we are just targeting close to the households where there are targets there in the environment where you can reduce even more the amount of insecticide.
And just in terms of the specificity as well, because I understand that some of these semichemicals, they come from other plants, if you can say what plants they might be. And also, I know you've done studies on bees. It mentions in the release
Exactly.
that it doesn't affect bees, but what about other insects?
So that's the deal. We are learning, we were really worried about bees and other pollinators. So when we looked at the formulations that we are using, we usually go and test for bees, at least. And if it doesn't attract bees, then we start looking at that chemical and trying to see, can we bring that chemical to the formulation. Then for certain beneficial insects, we do further tests. But whenever we go to the field, we do small trials. And during the small trials, one of the things that we look at is what are the non-target insects or non-target animals that are dying. Now, and based on that, we decide to keep or to exclude certain components, or even to bring repellents. Now, so this sweet formulation, one of the biggest problems with sweet formulations is that it attracts everything, including kids and dogs and lizards and you name it. So we put deterrents in there, like there's some bittering agents that we can add so kids don't even touch that. So there are tricks that we use in semichemicals that we avoid certain problems that are very basic. No. Thank you.
Ben Valsler from Chemistry World magazine. A couple of questions, really. I'm just wondering, is there a risk of bioaccumulation when you're targeting one species so closely? Because spiders, as you mentioned, lizards and so on, will eat the mosquitoes, and they will then get eaten by birds and so on. And we've targeted the mosquitoes rather than blanket spraying everything, which will, of course, knock the entire ecosystem down. This really sort of neatly introduces that insecticide into the food chain.
Okay, what we are doing, if you think about a tree, and if you're blanket spraying that tree, yeah, you're killing everything, so you don't have much bioaccumulation except on the tree and the animals that are going to feed that tree on that tree later. But think if you can put a little dollop that is going to attract and kill the mosquitoes in that area. That mosquito population, if it's really large, is going to go down very quickly. As you could see in Vectrax, the population just took a nosedive when we started applying the formulation. So the bioaccumulation initially might occur, but later on is going to be, because you are really targeting that species, the bioaccumulation is going to be not a problem. And I really think that if you can target something, you're much better off. For example, in agriculture, instead of blanket spraying the whole crop, we put one dollop in one tree, and we are done with it for months, where the grower has to spray every single leaf of that tree in order to kill that bug. Same thing here. People have to go with fogging machines and basically put that fog everywhere in order to kill the flying mosquitoes. Imagine if the mosquito comes half an hour later. That's not a flying mosquito. That mosquito is not going to die. It's not going to be effective on that mosquito. So with our formulation, we put it there, stays there, and lasts for some time, for a week, for 3 weeks, or 4 months, depending on the formulation.
And how do the sweet chemicals overcome the instinct in a female mosquito to be looking for a blood meal?
So that was the biggest question. When we went to Tanzania, we wanted to, the mosquitoes in Tanzania, the houses in Tanzania, they have holes in between the wall and the roof. And the mosquitoes, they enter the houses through those holes, through those gaps. And those are mosquitoes that are interested in blood meals. We were hoping that the females would stop for a sweet tooth meal, and we didn't know. So when we started seeing the nosedive happening in the field, we are very, very excited, because now what we did like females that are really going for blood, just the mosquito females that are really going for blood, those mosquito females, they actually stopped to go for a sweet sugar meal before they entered the room. And we didn't know that was going to happen, and it happened, and it's beautiful. You see the population goes down very, very quickly with tiny little amounts of insecticide. One of the things that when we looked at 18 villages and we selected 8. Some of these villages, imagine rooms like, I don't know, maybe the size of 3 tables like this, and a room like that where we catch more than 300 mosquitoes in one night. And that room has a bed net that has been treated with insecticide. So resistance to insecticides is tremendous nowadays. And the level of, I didn't know that if I have one mosquito in my room, I'm awake till I kill that mosquito. In Africa, in some villages, some of these rural villages, people are living under a huge, huge pressure of mosquitoes, and it's tremendous. So I think hopefully with this we can reduce the impact of these diseases, the impact of disease-transmitted mosquito-transmitted diseases.
You've mentioned agriculture a few times as well. Do you think the same principles could be used to target crop pests and not just human pests?
Yes, we come from agriculture. So in agriculture, we had to learn how to be extremely inexpensive, extremely effective, and use the semichemicals in a way that makes sense to the pocket of the grower. So what we are doing is the other way around. We are coming from agriculture into vector control, and vector control usually, like if you come from the United States, you look at the consumer market. The consumer market here can pay a lot to get rid of mosquitoes or whatever. You pay a lot, I pay a lot to get rid of roaches, etc. So products are developed with that huge price in mind. And when you go to countries like in Southeast Asia, South America, and Africa, there's no way to bring this area-wide. So what I'm doing is bringing solutions that are created to be used area-wide in agriculture, bringing to the vector control, trying to gain the effectiveness and the cost effectiveness of these formulations. No?
Thank you.
Thank you.
Question online?
Yeah, there's an online question. This is from Shankar Lal Dakar. Is there any physical method that can kill them, like radiation spectrum? Does that?
Yes, you can attract and kill mosquitoes. You can use radiation to kill them, but usually you have to have radiation very, very close to these mosquitoes. Actually, people use radiation to create sterile mosquitoes, which is one of the strategies that people use to control mosquitoes. But if you think about trying to control these mosquitoes in your backyard, it's very hard to have one of these radiation systems there to control the mosquitoes.
So I just have another question about the range over which these Semichemicals operate as well. If you could say something about the concentrations that you're using and the actual range at which they attract the mosquitoes. And also another question was, you mentioned that you're able to do this because you brought down the expense of manufacturing the Semichemicals. So
yes.
Maybe you could say a bit about that too.
Yeah, okay. So in agriculture, just in terms of the expense of manufacturing the Semichemicals, so we had to create plants to manufacture these Semichemicals in very large quantities for agriculture. Now, when we come to vector control, we simply borrow that system that is in place, and now we can do the same for these Semichemicals that we are using in vector control. How far these components work, we try to play this in different ways. For example, if you think about a good, I don't know, if you like French food, a good French restaurant, you're going to cross town to get to that French restaurant, okay? So, but if you think about grabbing something quick for dinner, you go to any fast food place, the closest one if your kids are crying. So the deal here is that what we try to do with this formulation is to make this formulation extremely accessible. It's a sprayable. We usually use sprayable formulation, so we can put like little dollops everywhere. So a mosquito that is coming out from a hiding space or coming from a lake or a body of water comes out, and the first thing that they find is that fast food that is going to kill them. It's almost like our normal fast food restaurants, and so they go for that. So we try to work with spaces that are not very large, but to do our sprayable formulations. When we work with larger traps and baits, that's when we try to increase the level of attraction in order to bring mosquitoes from far away to that trap. So we usually use that to monitor populations. Or with Aedes mosquito, which is a mosquito that lives inside houses, that's what we try to do with those mosquitoes. We have devices that attract them and kill them. But for these formulations, we want to kill the mosquitoes that are outside before they go and bite anyone, go after blood.
All right, thank you very much. The archived version of this session will soon be posted at bit.ly/ACS_live_DC. Please join us for our next press conference at 10 a.m. today on using the coffee ring effect to find out what's in your water. Thank you.
Thank you. Thank you all.